Okay, well, good morning or afternoon, whatever it is for you. This is the second part of volumes, finding volumes. This is called a volume of revolution. Let me make a couple of notes before we start. I have been told not to use red pens, so I will no longer be using red. It'll mostly be black or blue. We'll see if green shows up. Secondly, my computer's had trouble buffering, and after about 7 to 10 minutes, the computer freezes up, and I can never quite tell when that happens. I look and I see that that's happening, and so every time I look at the computer, I'll check that. If it's freezing up, I'm going to stop the video and do a part 2. So just get used to that. There's actually going to be 2 separate videos, even if they come in multiple parts, on volumes, the second part of volumes. So this is 7.3, excuse me, 7.3. I'm going to call this B, volumes of revolution. We've talked now about volumes of known cross-section. This is actually very similar to that. Here's what we're going to be doing. Imagine if I was to tell you, I want you to take some shape and I want you to revolve it around that x-axis. It takes a little bit of thought, and you may want to look up a YouTube video on volumes of revolution, and you probably could find something that works. But basically what's going to happen is this shape is going to revolve around there. And I don't know if you can see it or not, but what you would actually make is a cone. I was kind of a weird kid in school. I would take something like this, a piece of wire. I'd usually steal a paper clip, and I would spin it around. And I would actually see the shape that it's making. I don't know if you can see that, but it's a cone, basically, as it goes around. And then I would play with it, and I would make it go, like this, let's say, and I would spin that around. And you can do this yourself if you want to at home. And you would have some sort of shape. I was actually creating a volume of revolution. What we're thinking is that this is totally enclosed. Now, let me call this line f of x. And let's, for the sake of argument, say that this point is A and this is B. And we would then say we're going to revolve f of x around the x-axis, and we're going to go from x equals A to x equals B. So I actually could move A up like this, in which case what I would have is a truncated cone, or what you might think of as like a platform, like in a circus that somebody could stand on. So you're going to have to be given this information. So basically, it's this region here that's going to be revolved around, and we're going to get this shape. Well, this is actually very similar to volume of revolution. We have to know what that area is. Well, this distance here from f of x back to the x-axis is my radius, and the area of that circle is pi r squared, and f of x is equal to r. So the area here is pi times f of x squared. And then because of that, this would be from B to A. I'd put the pi out in front, f of x squared dx. And that would actually give me my volume of this particular shape. We'll put numbers to it here in a couple of minutes. But, well, you know what? Let's put numbers to it right now that I think about it. So let's say we were doing this, and we said we have the line y is equal to, let's just make it 2x. So that actually would look like this. And we want to revolve it around the x-axis. And what they're going to do is they're going to tell you it's y equals x, y equals 0, x equals, let's do 1, and x equals 3. So y equals 0 is that, x equals 1 is here, x equals 3 is up here. It's going to look exactly like that. My volume, this should have been volume, then will be pi times the integral from 1 to 3 2x dx. And that would then be pi x squared over 2 times 2 would give me x squared from 3 to 1. And this would be pi times 9 minus 1. And that would be 8 pi. And we would usually leave the pi in the answer. Let's do a second problem that looks just a little bit different. But let's say that we took and did y equals x squared. And y is equal to 0. And x is equal to, let's do 2 and x equals 5. We would then want to picture it. Y equals x squared goes like this. X equals 2 is here. 5, 0. It's this region. If you think about what it's going to look like, it's going to look something like that. Right? And sorry, I'm off the screen. I forget that I do that. And this then would be volume is pi from 5 to 2 x squared dx, which would be v is equal to pi x cubed over 3 from 5 to 2. And this would be 125 over 3 minus 8 over 3 and 117 over 3 pi would be our answer. And again, they usually leave the pi's in there. Now, I have been doing these problems where it goes to the x-axis is what I'm trying to say. But let's say we had something slightly different. Let's say that we had a problem like this. And again, I'll just do this conceptually at first. I have a shape that goes like this, a shape that goes like this, and I want to go from A to B. So the way that would be written is that we're going to take, we'll call this f of x and g of x. We're going to go the area between, or enclosed would probably be the way it's going to be worded, enclosed between f of x, g of x, x equals a, and x equals b around the x-axis. Now, if you stop and think about what's going to happen here, and let me use a different color, we'll see if we can see that. You're going to have this shape here, like this, and this one, but then you are actually then going to be cutting out from the inside this shape. And what you're going to end up with, it's hard to see it with my drawing, is that we've got a hole cut out of the middle. But really what's happening is if we're revolving it, it's this area that's being revolved, not this one. So all this comes down to is that we are going to figure out what the volume of that one would be, which would be pi from a to b f of x squared dx. And we are going to subtract from it this green area in the middle, which would be pi from b to a g of x squared dx. And this then would be, because of our rules for integrals, f of x squared minus g of x squared dx. By the way, it's not f of x minus g of x. It's the whole thing and subtract out what's in the middle. So let's do a problem like that as well. Let's say that we had, see if I have one. Oh, I thought I had a problem set up, but let's just try one. Let's say that we had the line y is equal to, or f of x. We'll do the same thing, the area enclosed by f of x, or y is equal to x cubed. Now, let's do y is equal to the the 4 square root of x, and y is equal to x plus 1 between x equals 1 and x is equal to 3. So if we graph that out, y equals 4 square root of x would look something like that. Y equals x plus 1 would look something like that. And we're going from 1, I don't know if it's right there or not, 1 to 3. First thing we'd want to do is know which function is on top, and it would be this one. Oops. Sorry about that. My computer kicked off for a second, and I wasn't sure if I was still here, but it looks like I am. So it would be this from 1 to 3. And basically, this would be our top function. We can call that f of x and g of x. And this would be then pi from 3 to 1. 4 square root of x squared minus x plus 1 squared dx. Now that one I would do on my calculator. Although we could do this easy enough, this would be 4x minus x squared plus 2x plus 1. And so this would be negative x squared plus 2x minus 1. And then we'd integrate that from 3 to 1 pi negative x cubed over 3 plus x squared minus x from 3 to 1. And I'll let you do that one yourself. Here's the problems that we're going to try in our book. We're going to do out of section 7.3. Problems 13 through 25. Okay. And there's one more part to this, Volumes of Revolution. I will do that video and get it posted probably pretty soon now. I have, but we'll take care of that. And anyways, go ahead and try those problems. And again, email them to me. And if you're having questions, let me know. Looks like that blue doesn't show up real well either, so I will probably stick with black. We may want to just do this problem. This would be, this right here was pi, and then we're integrating pi, and we would have negative x cubed over 3 plus x squared minus x from 3 to 1, and that would be negative 9 plus 9. I've done something wrong. Maybe I have them in reverse here. Yeah, there's something wrong, but you get the idea of what is supposed to be happening. So I'm going to stop the video at this point, and we will pick it up and do the other part of this here soon. So.